Okay. That's what these are. These are the trig functions. And again, and again, okay. And again, this is a lot to remember. I mean, you have SOHCAHTOA for these three. That helps a lot. The other three here, I don't know if there's such a device as SOHCAHTOA here, but we do have, really just by comparing the definitions, we do have these identities, so-called reciprocal identities. And that's what these are. So this is how I remember it. So cosecant of theta is 1 over sine of theta. So-called reciprocal identities. That's what they're called because when you do 1 over something, you're taking its reciprocal. We also have these identities here. These can also be proved algebraically, directly from the definitions. And also with these definitions, I wrote it here. These hold regardless whether theta is in degrees or radians. Doesn't make a difference. Theta is in radians or degrees, these definitions hold. I mean, there's other mathematical stuff you can do with these in calculus. But there, I think you have to assume theta's in radians. That's different. But here, whether theta's in radians or degrees, it doesn't matter. I put this in here, as a reminder, because this will come up. Okay? But what this is saying is if you do 1 over something, right, a fraction, you flip the fraction, you invert it. The denominator becomes the new numerator. The numerator becomes the new denominator. So 1 over, you turn it upside down. That will come in handy because if we know, for instance, sine of theta, then 1 over sine of theta we can easily get, thus we get cosecant of theta. If we know tangent of theta, right, get cotangent, you do 1 over that, which means from here, you can just turn it upside down. Not only that, I put this in here. Again, we're assuming that A, B, and C, the numbers are non-zero. These are never divide by 0. Here, sine over cosine, okay? Well, this will come in handy, actually, when we calculate tangent and cotangent over here. Basically, this is denominator, this C. This is what goes away. That will come in handy when we do tangent and cotangent. So essentially, this C down here, the denominator of each, so to say, that's what's going to cancel. It's actually not hard to show that. It's just basic algebra. Or you could just actually use the, the definition of dividing fractions. So it will come in handy. I figured it wouldn't hurt for me to put this here. So. But this also shows, as you can see, if we know sine and cosine alone, we can easily get all the other trig functions. So if we know what sine of theta is, cosine of theta, we can easily get the other trig functions. For tangent, for instance, yes, we have that definition, opposite over adjacent, but it's really just whatever sine is divided by cosine. Excuse me, it's sine of theta over cosine of theta, for instance. And for the others, you're going to do 1 over. So. All right, and this will come into play also, this famous theorem, Pythagorean's theorem. This says if you have a right triangle, right, A and B are the lengths of the legs, C is the length of the hypotenuse, and A squared plus B squared has to be C squared. It's really nice also, excuse me. That's really nice also because with the right triangle, if you know 2 of the side lengths, you can get the third one easily. Most triangles, that doesn't happen. So here's our first. Are there any questions though? Here's our first example. So let's say we have this triangle. It's the right triangle. We have the 90-degree symbol here. We also have this angle theta, as you can see. We don't know what theta is, but you'll see that's not going to matter. This side length is 3, this is 4. The hypotenuse is c, right? Well, let's find the length of the hypotenuse. That's just, Pythagorean's theorem, right? Here, I'm giving you what a and b are. And you're going to use that to get c. That's what I'm using here. Then after that, once we get c, we'll get the trig functions of theta. Even though we don't know what theta is, we can still get sine of theta, cosine of theta, and all that stuff. So for c, right, from Pythagorean's theorem, we know that c squared, is 3 squared plus 4 squared. The unknown goes on the left side of the equal sign. So from here, we get c squared is 9 plus 16, which is 25. So c squared is 25. We know the square. How do we get the number itself? We take squares. So from here, in other words, you get c is the square root of 25, which is 5. Okay, that's good. So we know what c is. We know all the side lengths. That's really all you need regarding trigonometry. I shouldn't say that. Since we know all the side lengths, we can now get sine, cosine, tangent of the angle. I put this here to help us remember. But for instance, sine of theta, right? That's opposite, right? Opposite, side opposite of theta divided by the hypotenuse. Comparing the two triangles, you can see that 3 is opposite, 5 is the hypotenuse. So 3, in other words, is the opposite side. 5 is the hypotenuse. So sine of theta is 3 over 5. Cosine of theta, that's adjacent over hypotenuse, right? So that's 4 divided by 5. 4 is the side adjacent to theta. Four is the side adjacent to theta. 5 is the hypotenuse, so again, we get this. And again, by SOHCAHTOA, tangent of theta is opposite over adjacent. So tangent of theta is 3 divided by 4. Opposite theta, adjacent to theta. Now let's do the other ones. Cosecant, remember. I mean, you could use the actual definition. I like to remember it as 1 over sine. And this is actually what I was saying. Let me see if I can get back to it. Here, you do 1 over a fraction, you invert or flip that fraction. That's what I'm doing here. 1 over 3/5, that becomes 5 over 3. 1 over 3/5 is 5 over 3. This should be secant. Let me fix that quickly. That should be secant, not cosecant. Sorry about that. But I did it again. There we go. Secant is 1 over cosine. That's 1 over 4 over 5, which is 5 over 4, right? 1 over means, again, you invert it, you flip it. 3 over 5 here got flipped to 5/3. 4/5 got flipped to 5/4. Cotangent is 1 over tangent. I mean, yeah, it is cotangent's cosine over sine. That is true. Here, I'm thinking of it as 1 over tangent, because we know what tangent is. So we get 1 over 3/4, which is 4/3. Okay, that's the second, but I'm not sure if we'll get to the, so yeah, we're not going to get to that. But let me just say this quickly. Sine and cosine have to be between -1 and 1. Although in this case, actually, in this class for now, they have to be between 0 and 1, sine and cosine. It turns out tangent can be bigger than 1 because hypotenuse is the largest size, the largest side of the triangle, the longest length. Sine and cosine have to be between 0 and 1. So if sine happened to be 5/3, let's say, then we know we did something wrong. All right, now we're basically, I think now we're out of time. So let me stop here. Okay. So if there are no more questions, then we'll stop here. We'll keep going with this on Wednesday. So again, the homework is, well, it will be posted today at 3. Okay. So